Okay, everyone, good day. Today we are going to look at another very important lesson. This is known as exceptions, actually exception handling. Now, before we get to the presentation, let me also tell you why this is important. If you look at how we normally run our programs, our usual programs, we start from the beginning and then we run some statements. We go to the next statement, and then we end the program. What if something goes wrong while you are running the code? Like, for example, let's say you want to so what if we along the time running this program, something goes wrong? Say we have an array for 5 elements and we try to accept the sixth element, right? So sixth element is not there. Or we try to say read a file and the file is not there. The file doesn't exist. Or we are trying to create a file and you don't have permission to create files in that drive or folder. So these are, we call it exceptions, as in they are not normal, isn't it? In a normal program, everything works. You will never access a wrong array element. You never have any problem of creating files or reading files. So that is a normal way of doing things. So when you are writing code, what we do is we imagining these issues that might come, and then we try to do if-then statements wherever the problem can occur. Say, for example, if someone is accessing an array, we need to have an if-then element there to say if the array element they are giving us is more than the array size, do something. Or if they are accessing a file, before accessing the file, we need to make sure the file exists in that folder. And if they're creating a file, we need to check whether they have permission to create that file, things like that. So these are lots of if-then statements that we have to bring into our code because we don't know which or what can go wrong. Yeah. Let me illustrate this with a little diagram. Now, let's say we will start our code somewhere. So we start our code somewhere here, and then we end our code somewhere here, right? Start and end. Okay. Under normal circumstances, you run the code from start to finish like this. And we assume everything is fine, right? And if you go beyond a normal coding where you may have to check the permission or space or any user mistakes, because sometimes users make mistakes. So in that case, we need to keep on, having various tests in the code, isn't it? Testing for user errors, testing for permission, various things we need to do. And then what we generally do is we handle the error and then either we come back here or we go out to the end, depending on the situation, right? So if the error is big where we cannot proceed, we just exit the code. Now, this kind of coding is okay, but you have to imagine a lot of stuff. You have to accept a lot of stuff here, isn't it? So not very good. And especially when you are dealing with input-output systems and users, things can go wrong most of the time. So we need to assume that things can go wrong, right? So there is another way of coding. This is an interesting way of coding where we let the program run assuming everything is fine, right? So meaning we allow the program to run as everything is okay. No if then else statement here, right? But we also have a mechanism to handle if something goes wrong, right? So those are called exceptions. So now, for example, if something is not correct for some reason, they will throw an exception, right? Only if something goes wrong. Otherwise, the program is running naturally. So these are called exception handlers, right? So their job is to take care of the code if something goes wrong. So this way, we write the code as if nothing is wrong, and we can ask the code if something goes wrong. We have a mechanism called throwing exceptions. We say throw the exception, right? And we decide what to do, whether to continue, whether to give an error message, whether to return. Depending on what you need to do, we will take care of the code, right? So this is a much more advanced way of coding than our typical if then else kind of coding there. So let's go through some theory behind this exception handling before we get down to some coding. So in fact, Java, just like the collection framework, also has the exception framework. So this is a very advanced, nicely organized way of handling exceptions. So it's a mechanism provided by Java programming language to handle unexpected or exceptional situation. So what is an exception? That represents situations where something goes wrong, and they allow you to gracefully respond to errors rather than letting them crash your program. Now, crashing the program is the worst thing that can happen to a program, where you don't have any error message, nothing, it just breaks. But if the program can catch the problem and then tell the user, hey, there is a problem. For example, I don't have permission to create a file, or your disk is full, then the user can retry. For example, let's say you're copying some file from your hard disk to pen drive. If the pen drive is full, it doesn't crash the program, right? It comes back with an error message saying your pen drive is full. What do you want to do? Do you want to cancel or do you want to try again? Now we can go out of that program and delete some of the files in the pen drive and try again, so that my program will complete. So this is called graceful response or graceful completion of my code. Yeah. So that is what do with the exception framework. So if you look at the mechanism, this is how it goes. Problem occurs, create exception, throw exception, and then handle exception. So we decide what to do when it comes to handling the exception. So what is an exception and why do we need it? It is something that it's an event, we call it. It happens when something goes wrong or something disrupts our normal way of instructions. So that is what we call an exception. And then why do we need that? I already explained you. By handling the exception system, we write clean code. Our code is very cleaner rather than otherwise your code will have lots of if-then statement, and your proper logic or your main logic may not be very clear to people because you are doing lots of checking and whatnot, right? Now, talking of exceptions, there are two kinds: checked exceptions, unchecked exceptions. Two types, right? So what are the checked exceptions? Now, these are the ones checked by the compiler, meaning your program will not get compiled if you have any of these exceptions, right? So the compiler will not compile your code. Unchecked mean it get compiled, but these are unpredictable situations like user errors or input output errors like permission, space, and things like that. Okay. So these are the two kinds of exceptions we have. So we can go to the details to understand what they are. Now here is the explanation of the checked exceptions. Now, before we go to the text, look at this code here. In this one, I am trying to get a file in the E drive with a file name file.txt. The file is not there, in fact. There is no E drive and there is no file. So when we try to compile this code, it will not work, right? And it will come back with the issue saying, look, there is a problem here. Okay. So this is an example of a checked exception. Now, here are some example of, in fact, a list of checked exception. I think there are a few more as well. So I picked up the most important, most notable ones. So the first one is IO exception. IO stand for input output. So represent any exception that occurs during input output operation, such as reading or writing files. File not found exception throws when attempting to access a file that does not exist. Then pass exception. Now pass means you're converting something to some type to some other type. Okay. And SQL exception is where if you're accessing a database, something is wrong with your SQL statement or database or something like that. And then class not found. So you're trying to load a class, but it is not there. Right. Might be to do with namespace, sometimes file physically not available. So things like that. Then instantiation exception. So you're trying to make an instance, but for some reason the class cannot create an object or the instance. So for some reason. Then illegal access. So you're trying to access a member, maybe it's a private member. So you can't access that, right? Then no such method exception. So you're trying to access a method, but it doesn't exist. Clone not supported. You're trying to clone an object and you cannot clone. You can't take a copy of that. Interrupted exception. This comes when you're doing multi-threaded applications. So we are trying to interrupt something while it is waiting for something or the other, right? Instantiation exception, where we are trying to create an object or an instance and it's not working for some reason. No such field. You're trying to access a variable or a field within a class and it's not there. And then illegal access. Again, something that is not possible to access. You're trying to access it there. So I think we'll type a little bit of a example before we get to the next one. So the next one is called unchecked exceptions, right? Now, if you look at this one, this is a very straightforward example. So I have a num array, integers. I have 4 elements, isn't it? 1, 2, 3, 4. And you know, when it comes to arrays, we start with 0 as the index number. So this is 0, 1, 2, 3. Now, if I say to access the 5th element, that is wrong because there is no 5th element, isn't it? So this will throw an error. And this error is not a compile time error, isn't it? Compiler doesn't see any problem in compiling this code. The problem will happen only when you are running the code. So you will get something called array index out of bound exception because array index is going bound. Bound is we only have 4 boxes. We are going to the 5th box. So it's going out of bound. If you look at the list of unchecked exceptions, here is a list. So we have null point exception, array index, which is a very common. Arithmetic is also very common, like you're trying to divide by 0, for example. Illegal argument, illegal state, class cast exception, number format. This is another very common one. This also you're trying to cast, like convert one to the other. Concurrent modification, this happens from multi-threaded application. Assertion happens when you are doing testing. Unsupported operation, this is also very common. Stack overflow and out of memory. And no class def also, where you're trying to find a class and can't load. It's not there. Okay. So before we get to that, let me show you an example by running some code on our editor. Okay, so if you notice this code, I am trying to read a file and my compiler detected the file is not there. See, it's red color already. I can't compile this. So it says unreported exception, file not found exception must be caught or declared to be thrown. Now, in one way, it didn't actually go to the hard disk to find the file. But what it says is kind of a warning saying, look, you are not handling your program properly. So this will not run. Yeah. Um, let's come back to this after one more example. Now, this is the, if you look at the code, we said checked versus unchecked. This is the checked version, right? So let me have another code. This is going to be a second example. So in this one, I am going to create a simple array and try to see whether I can access something that is not there. Okay. Let me copy this line again. Right. So here, now there is no compile time error. We don't see any red lines here. But this will certainly throw a runtime error because I only have 4 elements. I'm trying to accept the 5th element. So let's see. I'm compiling the code. There we go. We have a Java exception example 2 throws runtime error. So if you notice, what kind of error am I getting? So it says exception in thread main Java lang array index out of bound exception. Right? So index 5 is out of bound for length 4. I have only 4 and I'm trying to access 5. If I make it 4, this will work because there are 4 elements, right? Oh, no, because 0, 1, 2, 3, 4 elements. Now it works, right? Throws runtime error. So if I say 4, that means I'm trying to access the 5th element. Still wrong, isn't it? There. Index 4 out of bound for length 4. Right? So that's my issue here. Now, let's see how we can handle these issues. Now, okay, I might have to do a kind of an if then else, isn't it? If 5 is bigger than num dot, do you remember the length field, right? That means if actually we need to get an element variable. Now, see, a lot of work. I need to say int e equals 5. Is e bigger than num length? Actually, smaller than num length. Smaller than or yeah, smaller actually. Then I can say access here. I have to say e here, right? See, I have to do my testing within the code itself, the if then else statement. It's working, right? Now, if I say here, 6. Oh, actually, sorry. It works here. I need an else statement also. Here I need to say system.out.println index is bigger than the array size. Right? The index is bigger than the array size, so it's not working. Now, if I say 3, for example, there I can see the number, right? So now you see, I have to take care of if then else within my code, which is not very smart. Yeah. Now, how can we do this in a smart way? Let's see. So in order to handle exceptions, we have a mechanism called try-catch block. In addition to try-catch, there is also something called finally. So the code that you have within the try will be your normal code, as in the code that runs without any trouble. In case if something goes wrong, the code within the catch block will be executed. So your error management is removed from try and thrown into the catch block. Okay, these are the two normal or are the minimal code you need when you're using exception handling. The finally block is actually optional. Now, there are situations where after you, let's say, handle an error, you may have to do some, we call it housekeeping work, like giving back the memory or closing the file handlers, whatnot. So all that we can do within the finally block if you want to. And it is optional, by the way, right? So try block will throw the exception, as in if something goes wrong, that is the block, it will be throwing the exception. Catch block is where we are catching the exception and do something about it. And remember, catch also has a certain parameter coming in, right? So this is the exception type. Now, the types are here, these ones. Null point exception or array index out of bound. So whatever the exception type, you are catching here in the catch block. Okay. So here are some ways of handling this part. Now, if you are using standard coding where it can throw some errors, right? You don't need to write any extra code. You just write your normal code, and the compiler and the runtime system will take care of throwing errors. But there are situations where you also want to throw the error. You might have maybe a custom exception, or you may want to check yourself certain things using if-then statement. Then you can also throw an exception. For example, here it says throw new exception maybe, right? And if you are doing that, if you are throwing an exception, you need to normally start with this at the end of your statement. Now, for example, I have a method called deposit, and it throws remote exception, some sort of exception it is thrown, right? And only then you can throw. So this is generally used with custom exception management, which I'm not doing here. You can also write your own exceptions if you want to. But we are generally okay with whatever that is supported by Java platform because there's a comprehensive set of exceptions available for us. But when it comes to production level programming, we also create our own exception and we throw it out whenever there is not correct or not right. Now, coming back to our array program, what we wrote earlier, we can rewrite that code using a try-catch block. So we knew the exception that it was throwing was array index out of bound. Sometimes we don't know that also. Okay, so let's try both ways and see if you don't know what the exception is, what to do. If you do know, how to handle that, right? So I'm going to switch back to a coding editor. This time I'm going to create a new project. Let's call it W13C exception 3. In fact, I can copy this whole thing, right? And I'm trying to write this using try catch block. Let's see how it works. This is example 3. So rather than doing this if then else statement, I am going to use try catch block now. Okay, so it's pretty simple. You just need to bring in the try and then do your work and then catch the error when something goes wrong. So I can actually, I don't need this if then else statement. So I can say this is gone. Oops. I can remove all this, right? So maybe I can have a try block here, right? Try. There you go. I also need a catch block. Right? Here I need to say what am I catching? So and then do something about that error in case if I catch it. So since we know what kind of error we are getting, we can start with that error. Right. Oh, sorry, sorry. Array index out of bound. O is capital here. Out of bound exception. Right. I had a spelling mistake. Okay. So now I have this class. I have this object called E or EX actually exception. Right. Now exception also has by the way, it's an object, right? So I can let's dump that to the screen and see what do we get out of that, right? Now let's see whether it is working or it is not working. No problem, it is working. E is 3, it is working. Now let's put 5 here and see. Okay, you don't see error message, do you? There is nothing in red color, but I have an error. It says index is bigger than the array size, which is coming from here. And this is, by the way, is the exception from Java, right? Now, there is also something called get message here. So I can get message, right? This method I can call. So then it will give me the error message related to this exception. So let's run this. There you go. It says index 5 out of bound for length number 4. That is the error message I'm getting. All right. Now, let me comment this and copy this also again without EX. I'm just going to dump the whole thing. Now, rather than index out of bound exception, which I'm going to keep it this, what if I just say exception? Any exception for that matter. Let's say I don't know what the exception is. Any exception, I can catch it here. Now let's see what happens. Right, very nice. Yeah, I am still getting the same exception. This is very interesting because you don't need to remember what the exception is. You see, you don't need to remember. If you remember, fine. But if you don't, still okay. Yeah, you can still get the exception coming out here. All right, I can still run get message. It will give me the error message appropriately. Now, this is important because you can have multiple catch statement if you want to. So you can have another catch here, right? Another catch. So that's up to you. You can have one catch or multiple catches. So there may be situations where you might have permission issue, capacity issue, file name error issue, stuff like that. We don't know what the error is. The point here is in the try block. Now see, look at this code. I don't have any if-then statement here to look for errors, unlike here. Now here, I have to check the if-then statement before accessing my array. I don't do that. I just go ahead and access the array. So that's the beauty of running with the try-catch block. All right. So this is an example of how we ran the code with the help of try-catch block. And if you notice, the last block was always running, isn't it? Whether there is an error or no error, it is always running. Now, talking of errors, there is also error actually not error, exception hierarchy available in Java. You can break it down into two, errors and exceptions. Yeah, errors and exceptions. And exceptions also, you can break it down into two more things, runtime exceptions and other exceptions. Okay. Now, if you look at the hierarchy, look at the top one. The topmost is object, right? Every Java class is coming from the object class. Yeah. And from there, you have something called throwable. And there you have two things, errors and exceptions. Exception, again, we break it down into runtime and others. Now, if you look at the difference between errors and exception, we need to know that very well. All this time, we were handling exceptions, not errors. Exception means exceptional conditions that a program must catch. Whereas errors, they are so problematic, you have to catch it anyways, right? We can't catch them using try-catch blocks, but these are system throwing things, right? So maybe you can't catch them. Those errors might crash your system. So you have to be very careful there. Now, if you further expand this hierarchy, so on the top, we have the object, then we have throwable, we have errors and exceptions. Errors, you see, we have three: out of memory error, stack overflow error, linkage error. See, we can't do anything about it, isn't it? If this error happens, if an out of memory error happens, we can't do anything about it. Whereas under exceptions, we have runtime and IO exceptions. So IO means input output. Two things can happen. One is file not found, and then socket exception. A socket is where we will be talking to a server directly. So sometimes internet is not there, server is refusing. There can be a lot of issues there. Under runtime, you have illegal argument, arithmetic exception, index out of bound. Very common three things. And under illegal, you have another one, number format exception. Under index out of bound, we also have array index out of bound exception, which we got right now with our code. So this is the complex hierarchy in a nutshell, right? So we looked at how exceptions are working. We looked at this as a framework, right? Then we looked at two kinds of exceptions, checked and unchecked. Checked are runtime, compile time checked. Unchecked are runtime exceptions, because they cannot be checked by the compiler, because anything can go wrong during runtime. And then we looked at these examples, right? And we realized you need a try-catch block to capture and process the errors or exceptions. You shouldn't be using the word errors, because errors are different type in this case. And the finally block is always running, right? So we looked at how to throw an error or other exception, sorry. If you are doing that, you need to make sure you have this word throws and then the exception name. And after that, you can throw that error here. If you are throwing, by the way, right? And here's an example of exception management. Then we looked at the hierarchy. This is the basic hierarchy. Here's the detailed hierarchy. So the objective of today's lesson is to look at, or rather understand, how a new concept of writing code exists, where we don't need to worry about error management or exception management within our code. We write our code assuming there are no errors or no problems. And then we have a catch block in few places to catch if something goes wrong. Okay. Now, this lesson is very important going forward to get things like file access or network programming or multi-threaded programming, things like that. Now, in all those situations, we have to do exception management, right? So that is the lesson today. In our next lesson, we will look at files. Actually, we use the term stream because it can be file, it can be keyboard, it can be network. So we look at how to read information from streams and also how to output data to the streams.